So implicit differentiation, you see, everything we've been differentiating explicitly. But it is possible to differentiate implicitly. And there it is, that's the rule. It's exactly the same rule as what we saw as the chain rule, or when we were playing with rates of change. It's all the same idea. Now, y equals x squared. We can differentiate that explicitly. We can look at that and say, oh yeah, that's 2x. But what are we really doing? It's an equation. So what I'm really doing is I'm saying, I'm going to differentiate both sides of this with respect to x. So that's all I really put down there, d dx of both sides. On the left-hand side, I can't differentiate y with respect to x, but I can differentiate it with respect to y. And then using our little chain rule, I can multiply it by dy dx's. It's like saying, oh, well, the y's are cancelling, and so I do have d dx of y. Now, on the right-hand side, we don't have an issue because we can differentiate x squared with respect to x. So, all right, back to the left-hand side. Well, differentiate y with respect to y, I get 1. So 1 times dy dx equals 2x. Dy dx is 2x. That's what we're really doing. Now, of course, we don't write all of that down, but technically that's what we're doing when we differentiate. We are actually implicitly differentiating. So now, what that allows me to do, using that idea, if I have x equals y squared, now, normally we'd say, well, hang on, I can't differentiate that explicitly. Why? Well, because x equals y squared is not a function, and we differentiate functions. But by doing it implicitly, it allows us to differentiate things that are not functions. Let's see what happens. The left-hand side, I'll differentiate x with respect to x. I can do that. Differentiate y squared with respect to x. Oh, hang on. Can't do that. But I can differentiate y squared with respect to y, multiply it by dy dx. So in reality, I don't write this line down. I would go straight to this third line. I go, well, differentiate x, I get 1. I want to differentiate y squared. Can't do it with respect to x, so I'll do it with respect to y, but then I know I'll have to multiply it by dy dx. Now I just make dy dx the subject of the formula. Bang, 1 on 2y. I got my derivative, but it's in terms of the y value instead of the x value. Now, if you think about the picture, that makes sense. Because remember, this is not a function, it's a parabola on its side. If I was to substitute in the x value, there's 2 possible points, and they would have different slopes of the tangent. So which point am I talking about? Hey, if I substitute in the y value instead of the x value, then I go to the specific point I'm talking about, and I come up with one answer for the tangent. So that's the idea behind it. So if I wanted to differentiate the term x squared y cubed, so it's a mixture of x and y's, I'll use my product rule. Write down the first x squared, diff the second. Well, differentiate y cubed. Can't do it with respect to x, so I'll do it with respect to y, 3y squared, but I'll have to multiply by dy dx. Plus, write down the second, y cubed, diff the first, x squared, differentiate that, I get 2x. And so, it's an interesting answer, but the derivative of x squared y cubed, we get 3x squared y squared dy dx plus 2xy cubed. So if I want to find the equation of the tangent to a circle, so x squared plus y squared is equal to 9. I don't actually have to make y the subject to do this. I can just differentiate this implicitly. So differentiate x squared, that's not an issue, 2x. Differentiate y squared, can't do it with respect to x, I'll do it with respect to y. So I get 2y, but I got to multiply it by dy dx. On the right-hand side, differentiate 9, we get 0. Rearrange it, and eventually, where are we? There we go. The derivative is minus x on y. In this case, in order to find the slope, I need both the x value and the y value. Now, if you think about a circle, again, that makes sense. Because if you adjust to use an x value, you get 2 possible points. If you adjust to use a y value, 2 possible points. Use the x and the y value, it narrows it down to the specific point that we want. So sub in the point, 1, 2 root 2. We get the slope of that point is minus 1 on 2 root 2. We got a point, we got a slope, we can find the equation of the line. So let's sub it in. Y minus 2 root 2 equals minus 1 on 2 root 2 x minus 1. And eventually, there it is. X plus 2 root 2y minus 9 would be the equation of the tangent. Okay, now, it's not in our textbook because it's not in the course. In the old Cambridge book, it was exercise 7K. I think I printed it off, didn't I, to save you go looking that up? Yeah, so you got that there in the handouts. Let's have a go.